Another week for Python classes. Now, today we're going to have a look at an OUCC advanced Python question. Let's see what we have been working on before. I think we did Celsius to Fahrenheit last time. Oh no, that was was that last time? No. What did we do last time? Yeah, we did let's have a look. Oh, last week we were using inertial sensor using with Vex. So we're going back into pure Python. What was the last Python thing that we were doing? Just trying to think. Oh, proportional integral derivative. Okay. Well, we're going to do something different this time. All right. You hit open your browser. So open your browser and go to hallsoflearning.com and then hit the challenges link. Because the Bebris website is currently not showing their OUCC challenges, so we're going to do just a couple of Python questions and try to get a sense of how to tackle a Python question in an exam. Okay, so we'll go all the way down to senior, grades 10 to 11, OUCC round 1, practice A. Hit that link, hit start. Then let's start with odd number. Okay, so this is what a Python question looks like in an exam. Okay, it says a small program is needed. When provided with an integer n, the program should return the nth odd number. For example, if 4 is input, the output should be 7. Because 4 is looking for the 4th odd number. The first one is number 1, second is number 3, third is number 5, and the fourth is number 7. Constraints: n is greater than 0 and less than 10,000. This is just an idea for keeping you informed on what n will be tested on. Because you can't just say, for example, output the number 7. You can't just output a single number, because when this program tests you, it's going to test you with several numbers between 0 and 10,000. It's almost guaranteed to produce the 0 and 10,000 as well. Okay, it's going to use the minimum and the maximum, and then it's going to test a couple of numbers in between. So first of all, you set your compiler to be Python. And then your custom input data is what you enter to be the input. Okay? They say 4 is the input. Okay, this is for your testing. Okay? But remember, when they are actually marking you, they'll put in any number, several numbers between 0 and 10,000. And your program has to work for those numbers, but you don't know what those numbers are, because if you did, then you could just say print those numbers out. Right? So that's why it's going to say, okay, this is the example, so that you can test your answer yourself, but they're not going to tell you the exact test that they're going to give you. Does that make sense? All right. So in order to get this number, n equals, right? I'm going to set a variable. I'm calling it n because I want to create that a variable name that is similar to the question. Okay, n equals, and then if I say input, open close bracket, it will grab the first input line from the input box. But just like an input in Python, this input is in a string data type. It's a string format. So I need to turn it into an integer, int. Okay. After that, we will need to make sure that we understand how this question works. Okay, so I'm going to let's make a block quote here, okay? If n equals 1, the output is 1, okay? N equals 2, output is 3. N equals 3, whoops, output is 5. N equals 4, output is 7. Okay, and we need to work out what is the pattern here. What is the pattern? And the pattern is based around output. Okay, output is like y. Okay, so output equals something in terms of n. We need to make it in terms of n so that we can code that out. So what is the formula? The formula, for those who are mathematically inclined, so here's the thing, you can deal with these questions in a million ways. But today, this one, we're going to do with a math-first approach, okay? By using equations. If you've been use 7 or above, then you'll know what equations are. And you'll probably know some basic algebra, okay? So the output is equal to what in here? What is the pattern? The pattern is 2 times n minus 1. So the output is equal to 2 times n minus 1. Okay. You see how 3 is equal to 2 times 2, which is 4, minus 1, which is 3. 3 times 2 minus 1 equals 5. 4 times 2 minus 1 is 7. So that is how we work this one out really efficiently. All you have to do then is say print 2 times n minus 1. If you want, you can put some brackets around, but it's going to do it in the order of operations anyway. Okay? It's not that hard, isn't it? And you see how important maths is in programming, right? Submit the code. 4 out of 4, full score. See that? Oh, I just realized I have not been. Oh, hold on. Nope, that's good. I thought, I wasn't on showing my screen, because that would be very embarrassing. But I am, so that's good. All right. Now, what about if we try something a little harder? Let's go into Fahrenheit. Oh, let's do carbon. Oh no, carbon's too hard. I like hard questions. Let's do this one. Okay, a program. What we need to do here is we need to write a program that estimates the amount of CO2 emitted by cars. Okay, an average petrol car produces 100 grams of carbon dioxide per kilometer, with just a driver, plus 10 grams per kilometer for each passenger. Now, cars can be assumed to hold no more than 3 passengers plus the driver. So if there are more than 4 people who need to travel by car, 2 cars are required. So the inputs are the number of people and the distance in kilometers. Okay. So, for an example, if we put in 9 people and 1,000 kilometers, then we'll get 360,000 grams of CO2. Gives you the number of constraints. You gotta build the program that estimates this number. Okay, so here, same thing. 9 is the number of people. 1,000 is the number of kilometers. So what is it? The people, they don't really say what the variable could be, but yeah, we'll just go people. People equals the integer data type of input, the first one, right? The first line. That gets me the number of people, 9. Okay. Then the kilometers equals integer of input again, because every time you run this input open close bracket function, it grabs the next available line in the inputs. All right. So we need to work out. Oops. A few things. How to get the number of full cars, and then how many people in the remaining car. All right. If there is a number of people that isn't equal to the full number of cars, right? Because each car can only hold 4 people, but if you have a number that's not divisible by 4 cleanly, then you will have a car that has only got a partial number of passengers. So how to get a number of full cars, and how to get how many people are in the remaining car. Okay. So the full cars is this. The full cars is equal to the number of people divided by 4. That's only going to give you a decimal. So like 9 people divided by 4, it's 2.25, right? So I can't have 2 1/4 cars, 2 1/4 full cars, right? So it's actually people divided by 4 rounded down. Right? So here we'll say full cars equals people divided by 4, but I have to round that down. So to round something down in Python, you have to import math, and then you use a function called math.floor. Math.floor. That gives me the number of full cars, okay? Because it's going to get the number of people, divide by 4, and then it's going to round that down. So if it's 2.25, it's going to turn into just cleanly number 2. But now I need to find out how many people are in the remaining car. Well, how do you do it in maths? It is the people in the remaining car is equal to people divided by 4 remainder. Okay. So if I divide 9 by 4, it's 2, right? The remainder of that is 1. So that tells me how many people are in the remaining car. Okay. Is equal to people modulus 4. People mod 4, the modulus symbol, this percent sign, gets me the remainder of a division. Okay. Well, how did I know this? This is all just basic Python that after lots of experience, you will also remember this. All right, any questions so far? Okay, now I've got the people in the remaining car and also the number of full cars. So the full cars, so the emissions is equal to, remember a full car, one car gets produce 100 grams of CO2 with just the driver, and then plus 10 grams per kilometer for each passenger. So a full car produces 130 grams of CO2 per kilometer. So it's 130 multiplied by full cars multiplied by kilometers. Okay, but that's just the start. That just gets me the full cars. What about the people in the remaining car? Well, there's a few ways to work this out, but we need to work out if there is even any people in the remaining car. Maybe this we only have full cars. For example, if there were 8 people, then we wouldn't have any remainder. So we need to check. If people in remaining car is more than 0, then the remaining emissions equals 100. This is per kilometer. Hold on. We'll set the remaining emissions here. Why am I setting it outside? Because this is called scoping. If I set a variable here without setting it outside, then when I exit out of this this if statement, I won't be able to access it. So I got to put it in this global scope, in this in order to get it working. If people are remaining in the remaining car is more than 0, then the remaining emissions equals 100 plus 10 times people in remaining car minus 1. Because if there were just one person, it will just be 100 grams per kilometer. But for every extra passenger, I get an extra 10 grams per kilometer. But I need to take away the driver. So that is why it is 100 plus 10 times the people remaining in car minus 1, who is the driver. And then all of this is multiplied by the kilometers. Okay. So the emissions plus equals remaining emissions. That will increase my emissions by my remaining emissions, and then all I have to do is print emissions. Okay, and then I run the code, and then what should I get? I should get 360,000. Scroll down, and here we are, 360,000. Okay. If I submit this code, I should get a pretty good score, 6 out of 6. All right. So that is how to tackle a couple of questions using Python in OUCC. I hope everybody had fun tonight. I certainly did. If you have any questions, make sure you pop it into the comment section or send me a message for any questions. All right. I will see you again next week. Bye-bye.